Hello learners, and welcome to a video tutorial on how to pick apart a R circuit type problem so that you can get the equivalent resistance and you can calculate current coming out of the battery, voltage across each resistor, current through each resistor, so on and so forth. So the strategy here is to simplify what can easily be simplified first. And by far the easiest thing to simplify are circuits that are in series with each other. Series meaning there is a direct connection between the two resistors. So current is flowing in this way from my positive terminal of my battery, and I'll call that current I naught, just for the initial current drawn from the battery. Now that current flows through R1, and that current also flows through R7. Because of the junction rule, whatever flows out of the battery must be the same current that flows into the battery. Now, each of these resistors is going to have a positive and negative terminal. And if current, conventional current is going to flow from high to low potential, well then each side here is going to be a plus, minus, plus, minus, plus, minus. So this side closest to the positive terminal is going to be positive because current is flowing that way. Okay. Now, once this current reaches this junction here, it is going to split. And I'll call this current down here, we can call it I1. And this current up top we can call I2. Now, we don't know what those currents are, but we know that because of the junction rule, that those two currents will add together to be I naught. So it would behoove us to figure out what I naught is. And we are going to do that by figuring out what is the equivalent resistance of this circuit. So I'm going to start by simplifying R3 and R4. They are in series, so I'm going to simplify them as if they were one resistor. So I'm going to redraw my circuit and do just that. So those meet back up. We have one more set of parallel resistors, and then we have our last resistor. So there's R1, there's R7. I'm going to call this one R equivalent 3, 4 to show that it is the equivalent resistance for resistors 3 and 4. Now this one is still R2. I didn't mess with it. We still have R5 and R6. Okay. Now to get the equivalent resistance for 3 and 4, it would just be the sum of resistor 3 and resistor 4. Now I can simplify these two resistors here. So these two are in parallel. So again, R5 and R6 are in parallel, R2 and R equivalent here are in parallel. Parallel resistors, remember, it's the reciprocal sum. So I'm going to simplify again. I still haven't messed with R1, and I still haven't messed with R7. Yeah, R7. So there's R7, there's R1. Now this resistor is made up of these two resistors. So I'll call it R equivalent 2 through 4 to show that it's the resistance for 2 through 4. This one I'll call R equivalent for 5, 6. And let's show what each of those are over here. So this would be a reciprocal sum of these two resistors. So 1 over Req 2 through 4 would be equal to 1 over R2 plus 1 over this equivalent resistance, Req 3, 4. And we could show that if I carry this through, 1 over Req 2 through 4, 1 over R2, and then this resistor is just those two resistors added together. So I could go 1 over R3 plus R4. And I can plug in my values and I could actually get that equivalent resistance. For the equivalent resistance for 5 and 6, it's just a reciprocal sum of what is making up that resistor. And it is resistor 5 and resistor 6 being in parallel. So I've simplified my circuit down to 1, 2, 3, 4 resistors that are in series with each other. So to get the equivalent resistance for the entire circuit, I'll just call it R equivalent, that would be R1 plus R7 plus R equivalent 2 through 4 plus R equivalent 5 through 6. So that allows you to get the total resistance for the entire circuit. Now, we can plug in our values and we can solve for these variables. So R1 we said was 1 ohm. R7 was 4 ohms. Well, now we need to look at, okay, what is REQ 2 through 4? Well, it's right here. So let's do that on a separate board here. So I've got 1 over REQ 2 through 4, which is equal to 1 over R2, which is 3, and then plus 1 over REQ 3, 4, which we said was 1 over R equivalent, or excuse me, 1 over R3, which is 2, plus 1 over R4, which is 2 again. So this is 1/3 plus 1/4. Well, we're going to get a common denominator, so I'll go 4 over 4, and then 3 over 3. So this is 4/12 plus 3/12, which gives me 7/12, but I have to do the reciprocal. So REQ 2 through 4 is equal to 12 over 7 ohms. So come back to our total equivalent resistance here. REQ2 is equal to 12 over 7. Now we got to do R equivalent of 5 and 6. So 1 over R equivalent 5, 6 was 1 over R5 plus 1 over R6. And R5 was 4, and then R6 was just 1. So this is 1/4 plus 1, which is just 5/4, but again I have to take the reciprocal sum. So that gives me 4/5 an ohm. So plus 4/5 an ohm. Okay, so now we can just add all of our resistances to get the equivalent resistance. Okay, so that would be 5 plus 7/12 plus 4/5, and you get your R equivalent. Well, now, if the goal was to get the current and the voltage through each resistor, well, now we've got the equivalent resistance of our circuit right here. And if we know that the voltage of the battery is some number, okay? Let's just say that, let's just do this operation real quick. Let's go 5 plus 12 over 7 plus 4 over 5 equals some really awful number. It looks like it's 7 and 18/35 for our R equivalent. 7 and 18/35 an ohm. So hang on. 7 times 35 plus 18. So it looks like we got 60 over 35. That would be, wait, no. 35 times 7 equals plus 18 equals, there we go. Sorry. It would be 263 over 35. So let's just say, for convenience's sake, that our voltage is 263 volts. That's a lot of volts, but it'll make our calculations easier. So if our voltage is 263, and if I go V equals IR, well, the only current flowing through this equivalent resistor is the current of the battery. So if V equals IR, if my voltage is 263 and my resistance is 263 over 35, that tells me that I naught is 35 amps. Which tells me that if I go back this way, what made up R equivalent? Well, it was this resistor, that one, and that one. Each one has a current of 35 amps. And you know the resistance of each one, which means you could get the voltage of each of those resistors. Go back this way. You're done with R1 and R7. You've got the current and voltage through each one. What made up this resistor, REQ 5 and 6? Well, it was resistors 5 and 6. These two are in parallel, which means they will have the same voltage as what you calculate here. You know resistance and you know voltage, you can solve for current. Same thing for R2 and REQ 3-4. They will have the same voltage as this here. And this is ever so useful if I'll put it in the description, the circuit simulator. You can use this to check your answers and see if you figured out the right voltage and the right current. So again, what you want to do, you start with your circuit and then you gradually simplify down, getting R equivalent. Then you can work backwards to get the current and voltage through each.